Okay, to factor this binomial completely, the first step we need to do is see if we have a common factor. So something that can go into 144p squared and 36q squared. So sometimes it's not as easy to recognize the greatest common factor. So again, if we organize our work, it'll be a little bit easier to determine the greatest common factor. So what I'm going to do is I'm going to put the coefficient for the first term and the coefficient for the second term here. And then I'm just going to think of a number that can divide these both numbers evenly. So off the top of my head, I can think of 2. So if I take 144 and divide it by 2, I get 72, and 36 divided by 2, I get 18. And then I see, because these are still even numbers, 2 can go into both numbers. So 72 divided by 2 is 36, and then 18 divided by 2 is 9. This one's an even and this one's an odd, so 2 no longer can go into this, but I know that 3 can go into both. So if I divide 36 by 3, I get 12, and 9 divided by 3 is 3. And again, I can recognize that 3 goes into both of these. So 12 divided by 3 is 4, and 3 divided by 3 is 1. When I get to 1 here at the end, when I have a 1, it doesn't matter in which spot, then I know I'm done. So the greatest common factor would be this here multiplied together. So 2 times 2 is 4, times 3 is 12, times 3 is 36. So 36 is the greatest common factor. So the first step is I'm going to factor out this 36. Okay, so if I factor out this 36, here, I'm going to put my parentheses. I take 144 and divide it by 36, and I get 4. And then notice that I can't pull out any variables out here. So I get p squared. And then 36 divided by 36 is equal to 1. So I keep my sign, and then I put 1, and then q squared. Okay, so I have 36 times 4p squared minus 1q squared. So this one's a binomial, and I want to see if I can use the formula for difference of squares. Again, that formula, if you have a squared minus b squared, then the answer is going to be a plus b, a minus b. So I'm going to see if I can write this binomial as a difference of squares. Okay, so I noticed that 2p times 2p would give me the 4p squared, and then 1q times 1q would give me this 1q squared. So because I'm able to write it like this, as a term that's being squared minus another term that's being squared, then my answer is going to be 2p plus 1q, 2p minus 1q. So if you can write it as a difference of squares, then the answer would be, 1 plus and then 1 minus. And then of course we have to make sure we include the greatest common factor that we factored out at the beginning. So to factor the binomial 144p squared minus 36q squared completely, we first take out the greatest common factor, then use the difference of squares formula so we can come up with this answer here. So this is your final answer for the binomial 144p squared minus 36q squared factored completely.